Now let us move on to the open area test sites. Okay, open area test. This is some examples. This is the open area test environment. You can see the equipment is available here, and here from here it has been radiated. And open area, we are testing it. Okay, next, the measurement of radiation emission and radiator susceptibility of apparatus, equipment, two basic electromagnetic interference and electromagnetic compatibility measurements. As already we know, emissions and radiations are two different things. Okay, two basic. The purpose of radiation susceptibility test is to determine the degradation in the equipment and equipment performance caused by the external coupled electromagnetic. See, one is how much it radiates, how much it is capable, and whether it's within the limit. That we need to ensure that, again, for that the radiation emission we have to perform the measures, and that has been done in an open area environment. Again, the next one, is there any other external force that degrades the performance of your devices? That need to be tested. As I told you, another example which happened in Chennai, I told you that exactly their car making company, the car parts making company, are not able to communicate through their um, um, routers, Wi-Fi routers and wireless Wi-Fi routers, because at the same frequency there is some other equipments were working, that has been invented by using the spectrum analyzer itself, taking for rent from one engineering college. He able to identify and give suggestion to the people that I've told you already. That exactly what he did is he just when you ask when you hear this stories, it will be interesting, and it will look like just like that. What is this a common man can able to do? But that idea of switch off, switch on, and find whether which particular machine makes noise in that particular frequencies matter. So the external force is a noise. The machine which worked on particular frequency is a noise for that wireless router. So because of that, it is working, but it is not delivering it because more than that, and because the energy of that is very less. It's very poor, and the noise energy is very much high. The noise floor is very much high. Because of that, it's not able to communicate. So that information I already told you. That same thing has been given here as the purpose of radiation susceptibility. So it's nothing but susceptibility test. What he has done is susceptibility test. Okay. So open site measurement is most direct and universally accepted standard approach for measuring radiation emission from an equipment or radiation susceptibility of a component or equipment. So for both radiation and immunity, related to radiation, since it's open, it won't be used, it cannot be used for CE and CS. It can be used for only RE and RS. It's open area, radiations. So for radiation test, for both your radiation emission level and radiation susceptibility level you want to test, you can use this open area test sites standards, procedures. Okay, so an emission has to be within the standard, and the radiation susceptibility should be as much as high than the threshold. Okay, immunity should be as much as high. It should be. Okay, why use open area test? That's what I was just explaining. Again, this has been given here. If RE, RS measurements are done in a room or in a closed area, it is possible that reflection and scattering signal from wall, floor, and ceiling will be present. It is necessary if the measurement yields a true representation of characteristics being measured and lead to repeatable results. That's why we go for open area test. And defects, what is the defects? No immunity test procedures are allowed on this type of EMC facilities due to governmental regulations, because with curiosity, some people generates high radiations, and because of the high radiation the equipment burns, and then because of that fire, everywhere it gets like a forest fire, it gets spreaded, and a lot of loss will happen, a lot of loss in terms of economy, and then human life loss, all may happen. Okay, so that's why government regulations are there, and they put a limit for this. So you can't go beyond certain level of energy you can't produce, and then yeah, and those energies you can't, in that environment you can't create for the equipment which is under test, the device under test. Okay, so that's the reason. That's the only defect that cannot be taken as a defect. It's for a safety measure. The government has given these regulations, rules. So keep it that in mind. That's the only drawback. So that means big systems. I cannot test in see the aeroplanes and all those things. I cannot produce a much higher voltage and put it on this device in a open area because it's radiated and some people may cross birds. All those things may cross over, so that may get that may damage or even we may have a loss of life. So to avoid those things, in open area we are not permitted to generate a high energy. But at the same time, in anechoic chambers, small chambers we can't do, bigger chambers we can do. That we'll be discussing in the next discussions. Okay, so that's about it. So keep in mind the defects or the limits of this open area test is you can't generate much higher energy and then put your devices under that environment. That is not possible because the government norms are not permits that. So here one example how they perform the RE. See the RE is a radiated emission. So we'll have a power source. From the power source has been distributed through the power line filters. It has been given to the equipment and the test. So that means the equipment is operated. While the equipment is operating and energy is being emitted, okay, even energy is being emitted. So once you switch on, this is just simply switching on and then operate the equipment and the test. So now there will be a receiver. Well, the receiver is scanned over a specific frequency range. It will be scanning the frequency and from some low frequency to high frequency, and then measures and during for that frequency what is the corresponding electromagnetic emissions or electromagnetic strength that it will be receiving. So this receiver has been calibrated and just collect the signal and give, and that has been given to the field strength meters. So field strength meter, it may measure E field or M field. It will give the field details here. So and then after you get the details, we'll determine whether the these fields are within the limit or not. Okay, so that's the steps we have got for RE. Equipment is switched on, receiver is scanning over a specific frequency, and you start measure the electromagnetic emissions. Determine the compliance of these data with stipulated specifications. So that's the RE test. Next comes your RS test. In this case, it's ulta reverse way. What we do, we just equipment is placed in automatic field created with the help of suitable radiating antennas. We have to create the EM environment by using a suitable radiate antenna. We have to create the field. Intensity of electromagnetic field is varied by varying the power delivery of the antenna by the transmitting amplifier. So we have a amplifier over here. By varying the amplifier, we can vary the intensity of the EM signal over here. So different the same EM environment, it will be exposed to different level of EM strength. And now we'll check the performance of equipment, whether it is working normally or is there any change like automatic restart, any specifications being changed. All these things, is it happening or not, we'll check. Or how it performs, it is the normal way it performs or it is different, that will be testing. Okay, so you power up the antenna, create the environment, expose the equipment to this environment, change the intensity, and check even when the intensity is increased, it performs normally or abnormally, and that is what your measurement of RS. Okay, so here they're given the list of antennas which can be used for this purpose and different frequency range. For 1 to 30 megahertz rod antenna or loop antennas you can use. So for some higher frequency biconical antennas can be used. And if you go with 1000 megahertz, that is 1 gigahertz, up to 1 gigahertz means it's a broadband antenna. 30 to 1 gigahertz, 30 megahertz to 1 gigahertz of broadband antenna, dipole antennas are used. Even further much different antennas are used for this purpose. Log periodic antennas also can be used for this, and conical log spirals are used if you want to go for up to 10 gigahertz. 18 gigahertz means rigid waveguides are used. Above 1 gigahertz itself, waveguide antennas are used. So these are the antennas used for used as a testing antenna for your RS test. Okay, so this is the equipment and the test with the known field strength. These are the known field strength. Exactly, you can exposed to these field strength. Okay, so that's about the antenna part. So, but as you know, like the test antenna, the type of antenna what we use is depends on the frequency of operation. The equipment that's in what frequency range it operates, if you know, then around that you can check, or even 1-2 band up and down, you can just change and then check the antenna. Okay, so these are some examples. So you can see this is loop antenna, biconical antenna, Yagiyoda antenna, log periodic. We can say it's a log periodic antenna. This one is your conical log, and the final one is the waveguide antennas. Okay, so these are different antennas there. And measurement precautions, and we need to ensure that it is the environment is relatively quiet and free from strong signals. So that means if it is relatively quiet itself, it will have 6 dB attenuation, around 6 dB attenuation. Electromagnetic environment of open area test should be relatively quiet. The quiet the sense, and at least 6 dB below it should be. Yeah, the level when you measure the signal strength, it should be below 6 dB. That's very important. And the open area test should be free from electromagnetic scattering. There should not any scatter should happen. That's why open area has been chosen. And underground cables and pipelines also lead to electromagnetic scattering. So we need to ensure that it has been buried much deeper. Okay. Sorry, if not buried much deeper, it may be exposed to those things. Yes, of course. That's why we need to ensure that it's been buried much deeper. That's not cause any electromagnetic interference. A well-defined test environment. This environment is open area test environment is a well-defined environment, and it can be repeatable. That's very important. The metallic ground plane and absorptions of reflecting objects ensure that the measurement will be quite repeatable. Okay, so that's about measurement precautions. And some other information also, if you're keeping your test equipment stationary, and what should be the measures you need to take care of it. So you can see measure equipment has been kept here stationary, and there is two circles we have, and then where the first circle, the transmitter and the receiver antennas is there, that is your this, and the radius of that we call as SD, scattered signal. SD is the distance between the scatter circle, scatter distance from the device to the transmitting or receiving antenna place. And there is one more SC, that SC is the scattered signals boundary. After that there won't be any scattered signal, the boundary of obstructions and free area. So that is, so what should be the range in this? If you ask me, your SC should be the SC should be less than or equal to SD minus 6 dB. That we need to ensure. That's what, then only it will be below 6 dB. And how to choose the D? If you ask me, the D should be D dash. D dash is this distance. Should be 1.5 times of D. This is much greater length, radius. So this is the D, and the D dash should be 1.5 times of D and greater. So that's about D. When you keep your equipment stationary, that's your environment, open area test environment area. Around the equipment, you'll have a D radius, and there you'll have SD, scattered of the device scattering circle. Okay, and scattering circumference goes up to D dash, where the D dash is 1.5 times of D. This is the relation we have. Apart from this, what is the scattering level, if you ask me? And you should have the SD minus 6 dB of scattering level it will have. That's about it. So in case if you keep the antenna stationary, then what is the height and other information? So that's what has been explained here. See, the environmental area is called MD. The MD will be equal to 2D. What is D? D is the distance between the equipment and the antenna. Okay, and then what is the MD is the width and the major axis, and minor axis is MD. MD will be equal to small MD, that will be equal to square root of 3 into D. So 3 into D. It's a elliptical one. Okay, it's an elliptical one that you need to keep in mind in the case of stationary antennas. Equipment means circle, antenna means elliptical. That you need to keep in mind. Okay, so sometimes we need to know the height of the antenna also. Okay, you can vary the antenna height and then do the measures for a different type of concept. So you can see here it's a ground plane, and it's a receiver. This is your receiver antenna, and this is your transmitting antenna. Okay, transmitting antenna. What should be the height in this case? There can be, you can have the distance between the antennas, the equipment under test, and the transmitting or receiving antenna may have a distance of 3 meter, 10 meter, and 30 meter. Okay, if 3 meter or 30 meter, the height can be the scans, H2 scans from 1 to 4 meters. Okay, 1 to 4 meter. The H2 is this one, this receiving antenna. Scans from 1 to 4 meter. If you choose the 30 meter distance, then H2 scans from 2 to 6 meter. Antenna scan vertically and horizontally. You can perform both vertically and horizontally, you can scan. So that's about the height of the antennas in open area environment test. And this slide would have seen already. So these are the different examples of open area test sites. And this is the configurations, like as you know, like 3 meter, 10 meter, 30 meter are standards. And when it can be elliptical or it can be circular, both we have discussed in the previous slides. When it will be elliptical, when it will be circle, you should know. And if antenna is fixed, then it is ellipse. If the test equipment is fixed, then it is circle. So that is about it. And the antenna heights also can vary horizontally and vertically. You can vary. The range is already the range has been given already. So based on that, they have calculated the your MD and small MD by keeping the test equipment standard, the antenna stationary. For R equal to 3, what is the range, and our R equal to 10, what is the major axis, minor axis, has been given over here. Okay, next comes, these are the general information about the frequency range commonly used, what is the standard available, and what we are testing over here, what is the standard available, what is the cost is being shown over here. So open area test, the advantages: no multiple reflections, full compliance emissions, and the cheap investment and easy to construct. Drawbacks: weather influence lot, environmental influence is there again, regular maintenance is needed, it needs quite calm environment, which is very difficult. And another very important is no humidity test is allowed, because like we can't create the environment what we are looking for over here. Okay, so open area, so radiated only possible. And the dimension, as we know, dimensions needed is 60 cross 20 meter, or sometimes space needed will be 20 by 40 meter. Space is needed for this type of test. Okay.